Hello and welcome to this lesson on best practices for developing applications and other components for Android. In this lesson, we will cover some of the best practices, methods, and components for designing and developing applications for Android devices. Android runs on a variety of devices that offer different screen sizes and densities. For applications, the Android system provides a consistent development environment across devices and handles most of the work to adjust each application's user interface to the screen on which it is displayed. At the same time, the system provides APIs that allow you to control your application's UI for specific screen sizes and densities, in order to optimize your UI design for different screen configurations. The configuration of the screen on an Android device can contain many different components, offering a wide array of varieties of screen types that our application will need to generate appropriate UI for. These configurations can consist of several factors, like the screen size or actual physical size of the device, measured as the screen's diagonal, the screen density or the quantity of pixels within a physical area of the screen orientation from the user's point of view. Note that this parameter is dynamic and can change during the runtime of the application. And finally, the screen resolution, or the total number of physical pixels on the screen. Screen density of a device can vary greatly. This includes additional screen densities that have been added with the advancement of screen technologies. They now include LDPI, or low, which is usually approximately 120 dpi, MDPI, or medium, approximately 160 dpi, HDPI, or high, approximately 240 dpi, XHDPI, or extra high, approximately 320 dpi, XXHDPI, or extra extra high, approximately 480 dpi, and XXXHDPI, or extra 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 high, which is usually approximately 640 dpi. When designing your screens for this variety of different density types, it is important to use density-independent techniques in order to have your screen look as desired for the multitude of density type screens. There are 4 generalized sizes for Android screen sizes. Extra-large screens are at least 960 dp by 720 dp. Large screens are at least 640 dp by 480 dp. Normal screens are at least 470 dp by 320 dp. And small screens are at least 426 dp by 320 dp. For better support of multiple screens, you can declare the exact support screen sizes in the Android manifest. In addition, when developing for phones and tablets, size-specific layouts can be used by utilizing the Android Resource Qualifier system. In the same fashion, drawables of different resolutions and sizes can be assigned to corresponding density buckets. An important strategy is to use density-independent pixels, commonly utilized as the DP unit when designing layouts in XML. When appropriate, using the wrap content or match parent can help guarantee more consistent UI among a variety of devices. When designing your application for Android, it is important to utilize Android design patterns and practices. Build your apps to make best use of the unique Android features, such as widgets, rich notifications, sharing through intents, and other Android features and components. In addition, Google offers an array of components and features that can easily be included in your Android development. You can easily add the power of Google features like Google Maps, Google Drive, and single sign-on to your application. Android users expect high-quality apps. App quality directly influences the long-term success of your application in terms of installs, user rating and reviews, engagement, and user retention. Use the following design criteria to ensure that your app provides standard Android visual design and interaction patterns where appropriate for a consistent and intuitive user experience. Make sure that your app follows the Android design guidelines and uses common UI patterns and icons. In addition, your Android applications should support standard system back button navigation, and not make use of any custom on-screen back button prompts. Dialogue should be dismissible by using the system back button, and pressing the home button should navigate to the home screen from any point. Notifications in your Android application should follow Android design guidelines. In particular, multiple notifications should be stacked into a single notification object, when possible. Notifications are persistent only if related to ongoing events, such as music playback or a phone call. And notifications do not contain advertising or content unrelated to the core function of your application, unless the user has opted to see that information. In order to provide expected functional behavior, certain criteria should be followed, like only requesting the absolute minimum permissions that your app needs to support core functionality, that your application functions as expected when installed on the SD card if this feature is supported by your application, that audio does not play when your application is not in the foreground, unless this is a core feature of your application like in a music player. Unless required by the application requirements, the application should support both landscape and portrait modes and optimize graphics accordingly. Your application should also not leave any service running when the app is in the background unless related to the core capability of your application. As well, the application should correctly preserve and restore user and application states in between application sessions or when the application loses or gains focus. As with most software, performance and stability are critical components of having a successful and well-designed Android application. You should ensure that your application is stable and does not crash, force close, freeze, or otherwise function abnormally on targeted devices. The app should have as optimized performance as possible and should load quickly, and when running strict mode testing, no red flashes should occur. In the case of media being played in the application, all audio and video playback should be smooth. And in reference to visual quality, the graphics, text, images, and other UI elements should not be noticeably distorted, blurred, or pixelated unless this is by design and an aspect or feature of the application. Localization involves a variety of tasks throughout your app development cycle, and advanced planning is essential. A basic but important step in preparing for localization is identifying the countries where you'll distribute your application and the languages spoken there. Localizing your app is particularly important in countries where there is a large market opportunity, and English or another international language is not widely used. For international users, you can manage your application in three main dimensions: country, locale, and language. Of those, language is the key consideration for localization. Locale can also be significant because of differences in formats for dates, times, currencies, and similar information. Users control both the language and the locale used on their Android devices, and in turn, those affect how your application is displayed. Translating your application's UI strings and resources to your target language is the key place of localization, and it's one that requires the most care and planning. Early in the development cycle, contact professional translation vendors to get an idea of cost and turnaround time, and make sure to include multiple iterations in the cost. Where your app specifies dates, times, numbers, currencies, and other entities that can vary by locale, make sure you use the system-provided formats rather than app-specific formats. In cases where your UI can't accommodate text in one of your target languages, you can create an alternate layout for that language only. In your distributing to countries where right-to-left or RTL scripts are used, you should consider implementing support for RTL layouts and text display and editing to the extent possible. As described in the official Android developers blog, research has shown that speed matters for any interface, be it desktop, web, or mobile. In fact, the importance of speed is amplified on mobile devices since users often need their information on the go and in a hurry. And as Brad Fitzpatrick mentioned at Google I/O 2010, you can improve your app's UI responsiveness by moving long-running operations off the application's main thread. One way to improve UI performance is to minimize the complexity of your layouts. If you open up Hierarchy Viewer and see that your layouts are more than 5 levels deep, it may be time to simplify your layout. You should also consider using performance tools such as systrace and traceview to determine bottlenecks in your application's responsiveness. DDMS can also be a powerful tool set for determining sluggish or weak performance aspects of your application and improving them. The worst thing that can happen to your application's responsiveness is an application not responding dialog, or ANR dialog. Generally, the system displays an ANR if an application cannot respond to user input. Any aspects of the application that can or do cause ANR dialogues should be given the highest priority for optimization. Performance is one of the most important aspects of app development. Designing poor performing apps can cause users to dislike interaction with the application, and in more extreme cases, cause crashes and ANR dialogues. Random access memory, or RAM, is a valuable resource in any software development environment, but it's even more valuable on a mobile operating system, where physical memory is often constrained. Although Android's Dalvik Virtual Machine, or ART, perform routine garbage collection, this doesn't allow you to ignore when and where your application allocates and releases memory. To maintain a functional multitasking environment, Android sets a hard limit on the heap size for each application. The exact heap size limit varies between devices based on how much RAM the device has available overall. If your application has reached the heap capacity and tries to allocate more memory, it will receive an out-of-memory error. If your app needs a service to perform work in the background, do not keep it running unless it's actively performing a job. Also be careful never to leak your service by failing to stop it when its work is done. To be notified when your user exits your UI, implement the onTrimMemory method callback in your activity class. You should use this method to listen for the trim memory UI hidden level, which indicates your UI is now hidden from view and you should free resources that only your UI uses. Take advantage of optimized containers in the Android framework, such as sparse array, sparse boolean array, and long sparse array. The generic hash map implementation can be quite memory inefficient because it needs a separate entry object for every mapping. Additionally, the sparse array classes are more efficient because they avoid the system's need to autobox the key and sometimes value, which creates yet another object or two per entry. And don't be afraid of dropping down to raw arrays when they make sense. Listening and hearing your users can be one of your best tools for success. Start listening to your users before launching your applications and continue to listen after launch. Once you've published your app, Google Play makes it easy to see how it's doing. The Developer Console gives you access to a variety of anonymized statistics and custom charts that show you the app's installation performance and ratings. You should give special consideration to the usability of your application, and in particular the features of your application that are not being used or being used incorrectly. These features should be removed or modified according to the appropriate solution. In addition, you should consider adding features heavily requested by users to improve the usability of your application. A great way to deliver a delightful user experience is to integrate tightly with the operating system. Features like home screen widgets, rich notifications, global search integration, and quick contacts are fairly low-hanging fruit in this regard. The Android testing framework, an integral part of the development environment, provides an architecture and powerful tools that help you test every aspect of your application at every level from unit to framework. Android test suites are based on JUnit. You can use plain JUnit to test a class that doesn't call the Android API, or Android's JUnit extension to test Android components. Android instrumentation is a set of control methods or hooks in the Android system. These hooks control an Android component independently of its normal lifecycle. A useful general test class, especially if you're starting out with Android testing, is Android Test Case. It extends both test case and assert. It provides the JUnit standard setup and teardown methods, as well as all of JUnit's assert methods. In addition, it provides methods for testing permissions and a method that guards against memory leaks by clearing out certain class references. A key feature of the Android testing framework is its component-specific test case classes. These address specific component testing needs with methods for fixture setups and teardowns and component lifecycle control. They also provide methods for setting up mock objects, and some of the likely canons for this type of testing are activities, content providers, and services. The UI Application Exerciser Monkey is a program that runs on your emulator or device and generates pseudo-random streams of user events such as clicks, touches, or gestures, as well as a number of system-level events. You can use the monkey to stress test applications that you're developing in a random yet repeatable manner. Here we see a code snippet that illustrates how to test that an activity saves and restores its state as expected. We first start the activity, and then we get a handle for the spinner that is the activity's main UI widget. We set the spinner to a known position, and then stop and restart the activity, and assert that the spinner's position is still as previously set. Thank you for joining us in this lesson on best practices for developing applications and other components in Android. Join us in our next lesson where we'll cover aspects of submitting your application to the Google Play Store.